These are Raleigh-Smith's Chapter 19 FRQ test corrections. On Part A, my graph was kind of flipped. So wherever the velocity is at its max, you know that's where the kinetic energy is at its max, which means that that's where the potential energy is going to be at its min. And so that means that at like half between 0 and 0.5, this would be really small, and then the graph would kind of be like this. And I also needed to label like the potential energy amounts. And so whatever the max kinetic energy is whatever the max potential energy is going to be. So we can find out from the kinetic energy equation, which is 1/2 mv squared, what the potential energy max is going to be. And so you do 1/2, and the m is 0.125 kilograms, and the max velocity is 1.6. And so you get a potential energy of 1.6. Part B, I got all the points right except the acceleration amounts. And I got this right because I knew it was whatever this was flipped. But I did not get the acceleration right, because there are different values for that. And to find those, the force of the string equals kx or ma, but you need kx equal ma to solve for acceleration. And to find k, you need to do this equation: tension equals 2 pi square root m over k. Then you, after configuring it, you divide by 2 pi, and then you square both sides, and you eventually get to m 4 pi squared over t squared equals k. And then you plug that into ma. So we know the m, and we know 4 pi squared. The period is 1 second, because the period is 1 second. And so we need to multiply it by x. And since we have m on both sides, we can just cross it out. Multiply by x, well, that's just going to be the amplitude. Since this is 0.5 is like how it goes up, or the difference, I should say. So we know it's going to be half of that because it's going down 0.25 and going up 0.25, so that's 0.5 total. So that's the amplitude. So after plugging all that in, you get like 9.86, which you can just round to 10, and that's what it should be labeled on the acceleration. So I need to mention real quick that on part A, I said it was 1.6 for the potential energy, and I meant to say 0.16. Okay, so I missed a point here for not saying that, for not mentioning that multiple trials would be performed, but that would be needed if we wanted to get a graph. For part D, all that needs to be said is that you need to graph force over distance, and for the rubber band, and if the graph is linear, then the rubber band follows Hooke's law, which means that it is like an ideal spring. These are Raleigh-Smith's Chapter 19 multiple choice corrections. On part 1, I had B, C. C was correct, D is not correct. It'd be B and C, because to find the inertial mass, you would use force equals mass times acceleration. And on B, it says attaching the object to a force sensor, so you'd be able to get the force, and so you'd be able to find the mass, the inertial mass. On question 3, you can't add kinetic and potential, because from what we're given in the chart, we're given maximum speed of object, which means that would be the maximum kinetic energy. And so you can't add maximum kinetic energy with anything. It would just be maximum kinetic energy. So you could use either of these to solve. And you see here I got 3.8 for both. So you want to add them, the answer would be B. Question 8 is asking for the total mechanical energy of just the block, and then the block and the spring for this system here. So if it's just the block, it's not going to have elastic potential energy. So it's just going to have kinetic energy. And so when it's at the equilibrium position, it's going to be really high, and then it's going to be small when it's at its amplitude, and it'll go on like that, but it's going to go down because of damping. And then I got this part right because the block and the string will have both kinetic and potential energy, and if the mechanical energy is decreasing, it's not going to go low, then high, then low, and then high. It's going to decrease at a constant rate, or like gradually over time. And yeah, it's not gonna go up and down. And I know I made it clear, but I forgot to say the correct answer is C.